Rutherford's gold foil experiment is one of the most influential experiments in all of chemistry. It led to further improvements of the atomic model, replacing the plum pudding model presented by scientist J.J. Thomson. Let's see how Ernest Rutherford carried out his famous gold foil experiments, what observations were made, and what conclusions we can draw to arrive at the Rutherford model of the atom. This is the model of the experiment. To test if the plum pudding model was correct, Rutherford would fire alpha particles at a gold foil surrounded by a detector sheet. If the alpha particles would be deflected at small angles, this would be in line with the plum pudding model of the atom. What Rutherford found was that most of the alpha particles went straight through. Some were deflected at large angles, and some bounced back from the gold foil. What can we observe from these results? We can see that since a large number of the atoms passed through the gold foil, this must mean that most of the space of the atom must be empty, and hence arrive at the conclusion that a lot of the atom was just empty space. Since some of the alpha particles were deflected at large angles, this must mean that there was a positively charged particle somewhere in the atom. How do we know this? Since the alpha particle has 2 protons and 2 neutrons, it has a +2 charge. We know that like forces repel each other, and therefore we know that there must be a proton or a positively charged particle somewhere in the atom. And finally, some of the alpha particles bounced back, and this must mean that there must be a dense part of the atom that was positively charged. Rutherford therefore deduced that the atom must be mostly empty space, and that there was a dense, positively charged center of the atom, which was the nucleus, consisting of protons, with electrons surrounding the shell from a distance. And he was correct. He came up with this model, known as the Rutherford model of the atom. Thank you for watching.